Number 26. This reads, classify each process as a chemical or physical change. A, the condensation of water on the outside of a cold glass. Is this a chemical or physical change? Chemical and physical changes, I'll highlight these, chemical and physical changes, are discussed in lecture 2 and lecture 3. So if you want to go review on chemical and physical changes, the chemical change, this is number 26. I'm sorry, I'll start with physical change. A physical change is when a substance changes somehow, but the identity of the actual type of substance is the same after the change. So the substance is altered without changing its identity. Let's put it that way. Substance is altered in some way or another without changing its identity. And I gave a couple examples in the video. One was the melting of water. So, example, water melts. Okay, so if you have solid water, like an ice cube, here's a chunk of ice, and then you add a little bit of heat, and then it changes into this stuff, liquid water. Well, it's still water. And over here, we can even represent this as H2O solid and H2O liquid. You see, it's water before the change, and it's water after the change. Okay, chemical changes, on the other hand, do involve, a change in the identity. So the substances alter along with its identity being changed. So that's a chemical change. Now, sometimes it's just hard to tell this without a little bit of experience, but there are some good indications that you have a physical or a chemical change. Physical changes are easily reversed. Chemical changes are not so easily reversed. I'm going to write that down. So easily reversed. Okay, so it's very easy to solidify the water again. If you just cool this down, you put it in a freezer, it'll turn back into solid water, easily reversed. Chemical changes are not so easily reversed. And when you burn something, for example, I think we gave that as an example in lecture 3. We talked about burning. It's not so easily reversed. If you burn an object, you can't go backwards, at least not easily, okay? So just taking that information, let's look at A, B, and C. Okay, so A, here just underline this, A, the condensation of water on the outside of a cold glass. Okay, here you can imagine that you got some glass. Okay, it's cold. Maybe there's some cold liquid inside there. Okay, and then if you watch it for a while, you might see some little condensation occurring on the outside, some little drops occurring on the outside. And what's happening there is it's the water from the air, okay? The water vapor that's in the air is condensing to form liquid water on the surface of the glass. Okay, here you have water vapor. It's H2O in the vapor phase. We'll write that as H2O gas. That's what you have when it's water vapor in the air. And when it condenses on the surface of a glass, that's liquid water. Okay, H2O liquid. Okay. Now this is easily reversed. Okay, when water condenses, you have water that's floating around in the air. When it condenses on the surface of a glass, it's still water. Okay, that's a physical change, and it's easily reversed. If you just take this glass, you set it out in the sun, that water that condensed will re-vaporize and go back to the surrounding air. Okay, so it's easily reversed, and we should call this a physical change. So I'll just write PC, physical change, PC. Let's go back over here on the left side of the video, PC. Okay, what about B, mixing a teaspoon of instant coffee with hot water? Okay, mixing a teaspoon of instant coffee with hot water. Here, is it easily reversed? Okay, is it easily reversed? Well, yes, it is. When you mix instant coffee with hot water, that's kind of like you're, just dissolving it in hot water. You ever dissolved salt in hot water? Well, you can recapture the salt again, okay, just by letting the water evaporate. When you dissolve instant coffee in hot water, you can recapture the instant coffee by just letting the water evaporate. Here we can draw a little picture of this on the right-hand side. Okay, so here's your instant coffee, just a bunch of coffee grounds, and then here's your hot water. Okay, so it's hot here, hot water, and then when you put this in there, okay, then you end up, after it's dissolved, you end up with, your coffee, which is dark, okay, but the coffee is still there in the water, and you can get it back by letting the water evaporate. So you can just set it out, in the sun, and after many days, eventually the water will evaporate, or you can just boil the water off, and you'll see the coffee residue. If you let the water evaporate somehow, you'll see the coffee residue kind of sitting there at the bottom. So it's easily reversed. I would call this also a physical change. Okay, so you had coffee before it dissolved, and after it dissolves, it's still coffee in there, and you can recapture it. So physical change. Here, I'll put that over here on the left-hand side. Physical change. Okay, the last one, baking a cake. All right, anytime you burn something or bake something or cook something, it changes color, it changes its smell, the smell changes, color changes. Sometimes you see smoke, sometimes, it changes its shape. Those are all good indications that you have some kind of chemical reaction taking place. Okay, it's not easily reversed. You cannot take a baked cake and go back to the unbaked cake. Okay, not easily at all. So here, this is a this one part C. This is definitely a chemical change because it's not easily reversed. I should have colored the first two blue because physical changes, I was coloring them blue. Chemical changes are pink. Okay, hopefully that makes sense. And I think you can take a look at problem number 25, which asks you to do the same sort of thing. So take a look at these three and see if you can classify them. Okay, it's just like problem number 26.